Welcome to lecture 6 on conic sections. So, first we will find out the points of intersection of the line y equal to m x plus c with the parabola y square equal to 4 a x. So, if we see this parabola, y square equal to 4 a x is the parabola whose vertex is at the origin and the axis is the x axis. So, this is the equation of the parabola y square equal to 4 a x, and suppose we have some line y equal to m x plus c, then there are three possibilities. We can have this line intersecting the parabola in 2 points, or we can have the line which intersects the parabola in only 1 point, in which case this line is tangent to the parabola, or it can happen that the line does not intersect the parabola, for example this. So, we have three cases, this is line L 1, L 2, L 3. So, three possibilities. Which we can see from the graph are first 2 points of intersection, second is only 1 point of intersection, and third is no points of intersection. So, we would like to deduce the condition for all these three cases algebraically. So, to find the point of intersections, points of intersection of y equal to m x plus c and parabola y square equal to 4 a x, we solve. We put y equal to m x plus c in the equation of the parabola, then we get m x plus c squared equal to 4 a x. This is equivalent to writing m square x square plus 2 m c x plus c square equal to 4 a x, that is m square x square plus 2 times m c minus 2 a x plus c square equal to 0. So, the roots of x of this quadratic equation will give the x coordinate of the point of intersection, and then we can find the y coordinate using the equation y equal to m x plus c. Now, this is a quadratic equation. So, this is a quadratic equation in x. So, it has either two real and distinct roots, two real and distinct roots, or equal roots, which means there is only one real root, or two non-real complex roots. The condition for that will be, if we find the discriminant of this quadratic equation is given by 2 m c minus 2 a square minus 4 times m square c square, which is equal to 4 you can take out, and then we have m square c square minus 4 a m c plus 4 a square minus m square c square. So, m square c square can be cancelled, and this is equal to 16 times a square minus a m c. So, therefore, there are two points of intersections if a square minus a m c is greater than 0, that is a is greater than m c. So, this is the condition when discriminant is positive. We have 2 points of intersection. There is one point of intersection if the discriminant is equal to 0, that means a equal to m c, and no points of intersection if a is less than m c. So, these are the conditions. If a is greater than m c, then we get two values of x. So, we get 2 points of intersection. If a is equal to m c, then we get only one point of intersection, and the line is tangent to the parabola, and if a is less than m c, then there is no point of intersection. So, when a is equal to m c, the line y equal to m x plus c intersects the parabola in only one point, and hence it is tangent to the parabola y square equal to 4 a x. What is the point at which this is tangent? At the point we can see from this quadratic equation that when the discriminant is equal to 0, then x can be solved at the point x comma y given by x is equal to, for quadratic equation a x square plus b x plus c equal to 0, for equal roots we get minus b by 2 a. So, that is minus 2 m c minus 2 a divided by 2 m square. But in this case a is equal to m c. So, we can write this as minus 2 m c minus 2 m c divided by 2 m square. So, we get this is equal to m c divided by m square or c by m. And putting x equal to c by m in the equation, y equal to m x plus c gives y equal to m times x is c by m plus c, which is equal to 2 c. So, the line y equal to m x plus c is tangent to the parabola y square equal to 4 a x at the point c by m comma 2 c, provided m times c is equal to a. So, the equation of the line can be written as, so equation of the tangent line is m x plus c, and m c and a are related by this equation m c equal to a. Next, let us find the length of the chord. So, length of chord of parabola y square equal to 4 a x. So, if we have this parabola y square equal to 4 a x, and if we take any 2 points on this parabola what is the length of this chord PQ. So, suppose P has coordinates x 1 y 1 and Q has coordinates x 2 y 2. And suppose the equation of this line is y equal to m x plus c. So, length of the chord joining x 1 y 1 and x 2 y 2 on the parabola y square equal to 4 a x is L equal to square root of x 1 minus x 2 square plus y 1 minus y 2 square. Now, what we know is that the equation of the line joining x 1 y 1 and x 2 y 2 is y equal to the slope m here is. So, let me write in the form y minus y 1 equal to slope y 1 minus y 2 by x 1 minus x 2 times x minus x 1. So, this is can be written as y equal to m x plus c, where m is y 1 minus y 2 by x 1 minus x 2 and c is equal to y 1 minus this we are taking if x 1 is not equal to x 2. That means that if we take this chord such that the x coordinate of the PQ line is different, then because otherwise if x 1 is equal to x 2, then it is just the a difference in the y coordinate, which is the length of the chord. So, that can easily be calculated. So, note that if x 1 is equal to x 2, then length of chord L is equal to mod of y 1 minus y 2, and since we have y 1 square equal to 4 a x 1, let us call x, and y 2 square is also 4 a x. So, y 1 and y 2, y 1 equal to minus y 2 and y 1 minus y 2 in absolute value is just 2 times square root of 4 a x 1, which is 4 square root of a x 1. but in the case where x 1 is different from x 2, then this line is not parallel to the y axis and we have this line. Now, what we have seen is that x satisfies, so x 1 and x 2 satisfy the quadratic equation that we have derived is m square x square plus 2 times m c minus 2 a x plus c square equal to 0. Therefore, x 1 plus x 2, the sum of the roots of the quadratic equation is given by minus b by a. So, minus 2 times m c minus 2 a by m square, and x 1 x 2, the product of the roots is c by a. So, c square by m square. So, therefore, x 1 minus x 2 square will be x 1 plus x 2 whole square minus 4 x 1 x 2, which is equal to x 1 plus x 2 square is 4 by m to the 4 m c minus 2 a whole square minus 4 times x 1 x 2 is c square by m square. So, this can be written as 4 by m to the 4 times we have m square c square minus 4 a m c plus 4 a square minus, here we are taking m to the 4 out. So, m square c square. So, this cancels and we get this is equal to 16 times a into a minus m c divided by m to the 4, and y 1 minus y 2 is equal to m x 1 plus c minus m x 2 plus c. So, this is equal to m times x 1 minus x 2. So, therefore, the length of the chord in terms of m and c is given by square root of x 1 minus x 2 square plus y 1 minus y 2 square, which is equal to square root of x 1 minus x 2 square plus m square x 1 minus x 2 square, which is equal to square root of 1 plus m square times mod x 1 minus x 2, and we have got x 1 minus x 2 square is 16 a times a minus m c by m to the 4. So, this is equal to square root of 1 plus m square times 4 by m square square root of a times a minus m c. Okay. So, this gives the length of the chord. To get in terms of x 1 and x 2, we can put the value of m and c in terms of x 1 y 1 and x 2 y 2. To get the formula for L in terms of x 1 y 1 and x 2 y 2, we can put m equal to y 1 minus y 2 by x 1 minus x 2 and c is equal to y 1 minus y 2 by x 1 minus x 2 times x 1. Okay. Next, we will find the equation of the tangent line. So, equation of the tangent line to the parabola y square equal to 4 a x at a point x 1 y 1. So, let us take a parabola and suppose x 1 y 1 is some point on the parabola. We want to find the equation of this tangent line at this point x 1 y 1. So, suppose the line has slope m, then the equation of the line, of the tangent line is given by y minus y 1 equal to m times x minus x 1. That is y equal to m x plus m y equal to m x plus y 1 minus m x 1. Let us put this equal to c. We know that this line is tangent to y square equal to 4 a x if a is equal to m c, that is a is equal to m times y 1 minus m x 1. This is equivalent to writing m square x 1 minus m y 1 plus a equal to 0. So, what is the value of m from this? This gives m is equal to y 1 plus minus square root of y 1 square minus 4 a x 1 divided by 2 m is 2 x 1. But y 1 square is equal to 4 a x 1 because x 1 y 1 lies on the parabola. So, m is equal to y 1 by 2 x 1. So, the slope of this tangent line is m equal to y 1 by 2 x 1. This can also be written as m equal to y 1 square by 2 x 1 y 1, but y 1 square is 4 a x 1 divided by 2 x 1 y 1. So, x 1 cancels here and we get 2 a divided by y 1. So, we get this formula m equal to 2 a divided by y 1, and the equation of the tangent line is y equal to m x plus c was y 1 minus m x 1, which is equal to m is given by 2 a by y 1 times x plus y 1 minus m times x 1. If you see from this first equation, m times x 1 is y 1 by 2. So, this is equal to 2 a x by y 1 plus y 1 by 2. This implies if we multiply by y 1, y times y 1 equal to 2 a x plus y 1 square by 2. Now, let us put y 1 square as 4 a x 1. So, this is 2 a x plus 4 a x 1 divided by 2, that is y 1 equal to 2 a x plus x 1. So, this is the equation of the tangent line at the point x 1 y 1. This is equation of the tangent line to the parabola y square equal to 4 a x at the point x 1 y 1 on the parabola. Okay. So, we have derived the equation of the tangent line to the parabola y square equal to 4 a x at any point x 1 y 1 on the parabola. This can also be derived using calculus if you have learned about derivatives. So, let us derive this. Derivation of the equation of the tangent line using calculus. So, we have the equation y square equal to 4 a x. This is the equation of the parabola. Also x 1 y 1 lies on this, x 1 y 1 lies on the parabola. This implies y 1 square is equal to 4 a x 1. Now, we know that the slope of the tangent line at a point x 1 y 1 on any curve y equal to f of x is given by the slope is equal to the derivative dy dx at the point x 1 y 1. So, all you have to do is calculate the derivative dy dx. So, y square equal to 4 a x. If we differentiate this with respect to x, we get 2 y dy dx is equal to 4 times a, which implies dy dx is equal to 2 a divided by y, which will imply m is equal to the derivative dy dx at the point x 1 y 1. So, this is equal to 2 a by y 1. Note that we got this same formula m equal to 2 a by y 1 using our previous method, but that involved more algebra, whereas if you know calculus you can get this easily, and therefore, the equation of the tangent line is y minus y 1 is equal to m times m is 2 a by y 1 times x minus x 1 which implies y 1 minus y 1 square equal to 2 a x minus 2 a x 1, but y 1 square is 4 a x 1. Therefore, y 1 minus 4 a x 1 equal to 2 a x minus 2 a x 1, which is same as y times y 1 equal to 2 a x plus 2 a x 1, or y 1 equal to 2 a times x plus x 1. So, remark if you note this derivation, the above derivation, assume that this point x 1 y 1 is different from the origin 0 0, because we are writing 2 a by y 1 or 2 a by x 1. So, this assume this, but however, if the point x 1 y 1 is 0 0, so this is the vertex of the parabola y square equal to 4 a x, and if we take this point 0 0, then it is clear that the tangent line at 0 0 is the y axis. because y axis intersects this parabola at only 1.00. So, this equation is the y axis whose equation is x equal to 0. So, if we put x 1 y 1 equal to 0 0 in the equation obtained which was y y 1 equal to 2 a x plus x 1, we get left hand side is 0 equal to 2 a x plus 0, that is x equal to 0. Hence, the equation y y 1 equal to 2 a times x plus x 1 is valid for even the point 0 0. So, this is the general equation of tangent at point x 1 y 1. Next, we will find the equation of the normal line at any point x 1 y 1. Equation of the normal at point x 1 y 1 on the parabola y square equal to 4 a x. So, what is the normal line? So, if we have this parabola, if we take a point x 1 y 1, the tangent line is this and the normal line is the line which is perpendicular to the tangent line. So, this line we have, this is the normal line and this is the tangent line. The equation of the tangent is y y 1 equal to 2 a x plus x 1. So, if we assume if y 1 is non-zero, then we can write this as y equal to 2 a by y 1 x plus x 1. So, therefore, the slope of tangent line is given by 2 a by y 1, which implies slope of the normal line, let us call it m. This is equal to minus y 1 by 2 a, because these two lines are perpendicular, the product of the slope is equal to minus 1. So, we get slope is minus y 1 by 2 a. Therefore, equation of normal is y minus y 1 equal to the slope minus y 1 by 2 a times x minus x 1. Let us write this equation in terms of the slope m. So, in terms of the slope m, we have m is equal to minus y 1 by 2 a, that is y 1 is equal to minus 2 a m, and therefore, x 1 is equal to y 1 square by 4 a, which is equal to 4 times a square m square by 4 a, or this is equal to a m square. So, putting in the equation for normal, which is y minus y 1 equal to m minus y 1 by 2 a times x minus x 1, we get y minus y 1 is minus 2 m. So, y plus 2 a m equal to m times x minus x 1. So, x minus a m square, which is same thing as writing y equal to m x minus 2 a m minus a m cube. So, this is equation of the normal at the point x 1 y 1, which in terms of m, x 1 is a m square and y 1 is minus 2 a m. So, if we write a general point as a m square minus 2 a m on the parabola, then the equation can be written as y equal to m x minus 2 a m minus a m cube. Okay, so, next we will define what is called subtangent and subnormal and find their length for the parabola. Subtangent and subnormal. We have parabola y square equal to 4 a x. Suppose there is a point P on the parabola. Let us look at the tangent line at this point P, and suppose this tangent line intersects the x axis at a point T, and also let us draw the normal line and suppose the normal line intersects the x axis in n. This is perpendicular. Then is P T. Okay. Then we also drop perpendicular from this P to the x axis. Let us call that point as A. So, P t is the tangent between the point P and the intersection point on the x axis, and the projection of this on the x axis is A t. So, this A t will be called subtangent, and A n is the subnormal. This again, if you look at this, P n is the normal and its projection on the x axis is A n. So, this is subtangent, and this one A n is subnormal. So, if we take the coordinates of point P as x 1 y 1, we know the equation of the tangent line P t is y 1 equal to m times y 1 equal to 2a times x plus x 1. So, the coordinates of t can be obtained by putting y equal to 0. Putting y equal to 0 gives x equal to minus x 1. So, therefore, t is the point minus x 1 comma 0. This point is minus x 1 0. Note that this point A is x 1 comma 0, because P is x 1 y 1. So, this point T is equidistant from the vertex O and this point A. This vertex is equidistant from T and A. So, subtangent A t is equal to 2 times x 1, and what is A n, the subnormal? So, to find this subnormal, note that this triangle T A P is similar to triangle P A N. Why is this? Because if you see, suppose this angle we call theta, and this is a P A T is a right angle triangle. So, this angle will be pi by 2 minus theta. Again this is 90 degrees. So, this angle is theta. So, angle A T P is same as angle A P N, and then there is one 90 degree is common. So, therefore, these two triangles are similar, and therefore, if I write A n divided by A p, this is same thing as A p divided by A t. In the similar triangles, we know that the ratios are the same. So, this implies A n equal to A p square by A t. But what is the length A p? A p is nothing but y 1, this is y 1 square by A t is 2 x 1, but y 1 square is 4 a x 1 divided by 2 x 1. So, this is constant 2 a. So, therefore, subnormal a n is equal to 2a, which is a constant. So, subnormal does not depend on the point x 1 y 1, whereas subtangent depends on the x coordinate of the point x 1 y 1. So, we will stop here for this lecture. In the next lecture, we will do some more problems involving tangent, normal, etc. Thank you.